Hello everyone, greetings from Group 1. This is our project, Automatic Dam Shutter Controlling System. So, what is a dam? A dam is a barrier that stops or restricts the flow of surface water or underground streams. Reservoirs created by dams not only suppress floods but also provide water for activities such as irrigation, human consumption, industrial use, aquaculture, and navigability. Dams generally serve the primary purpose of retaining water, while other structures such as floodgates or levees are used to manage or prevent water flow into specific land regions. So now the component lists of our project. At first, we use a self-made linear actuator with mating from DC motor and screw. Two acrylic box joint and a hole inside. Acrylic shutter dam. Arduino Uno. Sonar. Motor driver LM298. DC supply.
Now we will see the construction of linear actuator. Here we are observing the mechanism of our linear actuator. The basic working principle of electric linear actuators is to convert the rotatory motion into linear motion. This conversion of motion is done with the help of a gearbox and a lead screw. These are the two most important electric linear actuator parts. When motor is rotating, screw coming out, and while rotating reversely, screw goes in. This is the linear actuator we have made in our project. We added the door of the dam with the screw of the actuator. Actuator is basically built with a DC motor which rating is 5 volt.
Now let's come to the working principle of our project. At first, dam water. Water height of the dam is minimum 17 cm to open the shutter and 10 cm to close the shutter. Then sonar. Sonar will measure the water level and set it to Arduino. In Arduino code, maximum minimum water level is provided to open or close the gate and then determining the polarity of voltage across the actuator. Motor will start to rotate after getting proper voltage. We have used a motor driver to ensure best performance from actuator. If water crosses the maximum height, dam will be opened, and when water level decreases to certain level, dam will be closed.
Now I will describe our setup. This is the full setup of our project. Our setup is pretty simple. Here we can see the side view of our model. To model a dam, we have made this rectangular box. Here, this middle portion is the dam. This is the motor that controls the gate. There is a sonar section behind the motor which you cannot see here. We can think of this right side as one side of the river and the left side as other side of the river. That gate controls the flow of water from right to left. Here is the sonar sensor. The working principle of sonar is pretty simple. It has a transmitter and a receiver. The transmitter sends a ultrasonic sound pulse and receiver receives it. The sonar counts the time between sending and receiving. Then, using the velocity of sound in air, we can calculate the distance. We have used the sonar sensor of ACSR04 model. It has 4 pins. This left one is the VCC, the right one is the ground, the middle two are for triggering and receiving echo. This is the motor driver of our project. The model is LM298N. It provides the DC motor enough voltage to rotate. The voltage from the Arduino pins are not regulated enough to run the motor. That's why we have used this module. These 2 pins are from external power supply. This green wire is 12-volt pin of the DC source, and this black one is the ground of the DC source. This blue one is not used. These two wires came from Arduino pin 6 and 7, and these two wires are the outputs of the driver. They control the direction of the rotation of motor. Now comes the Arduino part. It is the decision maker part of our project. We connect digital pin 2 and 3 to the Sonar circuit. And upon receiving the signal from Sonar, it takes a decision whether to open the gate or to close the gate. The pin 6 and 7 of this Arduino controls the motor driver. They goes to the pin number of in1 and in2 of the motor driver, and the output of the motor driver controls the motor. Now we have written the code on Arduino IDE and uploaded using USB cable.
This is the simulation part of our project. Let's first look at the input parameters. As you can see from the code, there is a dam height is 27 centimeter, open height is 17 centimeter, and close height is 10 centimeter, which means when the height will be over 17 centimeters, the gate will start opening. When the height will be less than 10 centimeters, the gate will start closing. And when the height will be between 17 and 10 centimeter, the gate will neither open nor close. Now let's run the simulation. As you can see, the height is 8 centimeters, which means the motor is closed. As you can see from 0 RPM is that motor is not activated. Now let's increase the height of the water and let's see what happens. As you can see, as we increase the water height, the speed of the motor has increased, which means the gate is opening. And let's reduce the height of the water and see what happens. As you can see, the water height is 13 centimeters. That means the water height is between the open height and closed height, and we can also see is that the motor is closed. Now let's reduce the height and see if the motor is closed or not. As you can see, negative RPM, which means the motor is closing.
This is the dam gate which we made controlled by linear actuator. This dam gate opens or closes according to the height of the water level. This is the whole circuit of our project. Here DC motor of linear actuator is connected to the motor driver, which helps the DC motor to get regulated voltage, and the motor driver is connected to the Arduino board. Thank you.